Welcome back. So I can tell we're having a little bit of connection troubles again today, and that's fine. We'll just use the recording. That seemed to work fine last week. First note, I did grade all of your high-low assignments, and they were pretty good. One thing I want you to work on, a lot of you are kind of sloppy with your variable names. So I'm seeing things like, Jose is a variable name. Jose is a perfectly great person name. It's not a good name for a variable. You want your variables to actually describe something in the program, like user guess or correct answer or something like that. So be thoughtful about that as you're making your variable names. Other than that, they were mainly pretty good. So good work. Keep on moving. The problems are getting trickier. I am in the process of grading the cryptos right now. So be watching for that. All right, well, let's move forward on today's topic. And that is, okay, we've built some basic user interfaces in Swing, and now we want them to be able to do something, right? I mean, it's not much fun to have a program if it doesn't actually do something. I'll show you what we want it to do when we're done. Okay, run this. We want to have a little program. Where'd it go? It's little, I know that, but there it is, where it says, please type your name. And I can type my name, Andy, Destroyer of Worlds. And I can hit click me, and it says, hi there, Andy, Destroyer of Worlds. Pretty cool. So this is sort of the classic hello world of GUIs. Not only can I print something on the screen, which we did last week, but now I can take some kind of input from the user. We can process that input on a button click, and then we can send the result to another place on the screen. Well, this seems incredibly simple, but it isn't really. There's a lot of kind of crazy stuff that has to happen to make this work. So that's what we're going to go over together today, is how we can start to build a slightly more complicated user interface, and then how can we make it so that we can actually do some input and output through the GUI. All right, well, let's begin. We're going to actually have to begin at an earlier program, and as always, these programs are available right here for you to look at, and this video will also be linked on Blackboard as soon as it's done. Okay, so we're going to start with this program called HighUserJava. All right, so let's see what's going on here. We're importing java.auth and java.swing. Remember, java.auth is the older library. javax.swing is the newer one. It turns out we usually use both because a lot of the Swing components actually relate to auth as well. So we'll bring both of those in for now. There's one more we'll bring in a little bit later. But that's going to give us our graphic tools. Now, class HighUser extends JFrame. Well, you remember, this is a pretty important idea. This is why inheritance is such a big deal. Because how do I get something to act like a JFrame? Well, I inherit JFrame. That's how. And so if I want to make something that acts like a frame, like a window, well, I need to find a class in Java that does it and extend that. I happen to have the Swing library open, and we can see all these cool things. There's a JFrame, and a JFrame can do a lot. Remember, a JFrame can do a lot by itself, and it also has a rich inheritance tree it can get things from. So it has several constructors. So there's different constructors we can use. Honestly, we'll probably only use this one and maybe that one. That sets up a title. It has a bunch of methods which we may or may not ever need. That's one we use sometimes. That's one we use sometime. Where to go? Set default close operation. So that's pretty cool. All right, so we can. So that's pretty interesting. It has a bunch of methods inherited from the auth frame. It has methods inherited from window, container, component. My goodness, a lot. So we're not too worried about all these. We just know, okay, how do I make my program act like a JFrame? Well, inherit JFrame. Okay. So class HighUser extends JFrame, and now we're just like a JFrame. We can do everything JFrames can do, but we're going to add some new features. Now, typically, the next thing you'll do is you will create local instance variables for your components. Now, wait, I thought we weren't supposed to do globals. Well, we don't. You can't really do global variables in Java. I can use instance variables that belong to the class. So inside the class, I can create a J label called output. And that's going to be my new J label for output. Oh, I get it. I bet that's a J label. And we can look at the J label in here and see what it does. E, F, G, H, I, J, K. Okay, there's the J label. And we can look at all of its constructors and methods and properties, and you may not understand all of them, but that's okay. We're just still say, okay, this is the things I could do with it. So I can make a new J label, and I believe I can even give it an initial value. Oh, cool. Okay, so I have a J label called output, which is a new J label output. Now, last time we didn't really name it, but this time we're going to make an instance of the J label, and we're going to give a variable name so that we can reuse this later. Likewise, we're going to make a J button. And the J button is going to say click me, and we're going to make a J text field for input, which we're going to call input, and its default value is input. So everything's making sense so far. Now I have created these objects, but they're not actually on the screen yet. I'll actually have to do some other work to put them on the screen and modify their characteristics. Okay, but it's nice that we can instantly see a lot about what's going on. When you create a GUI in Java, you pretty much always create all of the components as instance variables. All right, now in the constructor is where we're going to do all the interesting work. The first thing we're going to do is call the parent class super HighUser. So JFrames, we can pass a string in that becomes a new title. So we'll just say, all right, make my parent and call its title HighUser. Okay, that's good. Now remember, this part allows us to get something off of the back of the component that we can hang all of our various labels and so on. So we have a container called surface. The get content pane allows me to go get that surface object, and I'm going to give it a name. Now I attach everything to that surface. The way I think of it is sometimes you go to a store or you look in somebody's garage and stuff, and they have like a board with a bunch of holes and hooks on it. You don't hang stuff directly on the wall. You hang stuff on the hooks, right? That's what this is the surface allows you to sort of hang all of your components onto your JFrame. Okay, so this .get content pane. Let me skip this line for now. I promise to come back. Once we have a surface object, we can add our components to it. So I can add the output. That's the thing I made up here. We can add click me. That's the thing I made right there. And we can add input. So all that makes sense. We create our objects and we add them. The question is, how does it know where to put them or how big they are? That's actually a really good question. And if you've done programming in a language like Visual Basic or C# or something, you could draw the various components on. And that felt really good because you felt like you were writing a program without having to do any code. Problem is, it really doesn't save you that much time, and a lot of times you really want it according to a formula. And so the way that Java typically does it, now you can find tools that allow you to draw it like Visual Basic. I don't like them. When you know how to do it in Java, it's actually easier. Java comes with programming code. It comes with basically robots that set your layout up for you. And these are called layout managers. We'll talk a lot more about them later. But the one we kind of want to use right now is called the grid layout. And the nice thing about the grid layout is that it allows us to set up our entire applet as a set of rows and columns. So I say I want 3 rows and 1 column. And when you look at this program running, I'll run, then it's interesting that it knows what to do. Even if I resize this thing, it says, oh, okay, I want all of my components to be in 3 rows, 1, 2, 3, 1 column. There are many other layout managers, and we'll talk more about them probably next week. But the grid is nice for something simple like this. It's pretty easy. What if I did 1, 3, just for grands? Let's try it. Okay, so we'll save that. Compile it. Come on, baby, run. There it is. Okay, that's pretty ugly for this one, but yeah, we could do it that way. Could we do even crazier things? Like what about 2, 2? Sure, let's try it. Now for this particular app, that makes no sense at all, but you could do it. Okay, we'll talk more about this guy another day. Let's go back to what makes the most sense, 3, 1. And we'll run it. So we're saying, hey, layout manager, you decide how big things are and where they go, and I'll just add them. And once you understand how these work, you can get some very sophisticated user interfaces without a lot of work. All right, so that's pretty cool. So now we've set the layout manager to say, hey, set these things up in a grid of 3 rows and 1 column, then add the output, add click me, add the input. Now remember what the pack does is the pack says make it as big as you need to, but no bigger. And then set visible true makes this thing visible. So here's the really great news is that we're done. We're done with this code. It actually is running pretty well. So run it. Come on, where'd you go? So look at that. We've got a label that does what labels do, just kind of sits there. We've got an input box, and this is interesting. I can actually type stuff in there. Hi there, world. How does it know how to do that? Well, we inherited that behavior. That came from it being a J text area. And even the button, right? The button does what buttons ought to do is, well, when I put the mouse over it, it turns all blue and stuff, and then sometimes it looks like it gets pushed in. How does it know how to do that? Well, because I inherited from J buttons. So I don't have to know how to do all of those details as long as I have inherited from the correct thing. So that's pretty awesome, except there's a little bit of a problem with this thing. And that is when I type in my name and hit click me, it doesn't say, hi there, Andy. That was the point of the whole thing, wasn't it? But it's not working. And the reason it's not working is that we have to figure out how to attach an event to this button. So far we've talked about objects having properties. Those are characteristics, right? Those are things about it. And methods, those are things that it can do. An event is a little bit different. So an event is something, it's responding to something that happens to the object. So the thing about buttons is they're designed to be clicked. So somehow I need something to happen when the button gets clicked. And that seems a little tricky. Right now I haven't done anything here to make that happen. So I'm going to try and fix that. Now I want you to know there will be a problem with this next one, but that's okay. I want to just show you what we're doing. So the basic way to do that would be to have a special object called an event handler. In Java, pretty much everything's an object. So in order to handle the event, I would need some sort of object which can handle events. And the good news is in java.auth.event, there are a set of event handlers. They're really nice. And if you look here, I've done something a little bit different. Down here, I've made this thing called class event handler. Now, typically, up till now, you've only had one class in a file. Well, you can have more than one class in a Java file as long as only one is called public. So I've made a secondary class called event handler. Now, what's event handler? For now, I'm going to slightly lie to you. Implements ActionListener is basically like extends ActionListener. So what I'm saying is pretend ActionListener is a class. We've got an event handler that extends that. Okay, that's fine. That's super good. Everything's okay. So ActionListener is a pre-built class, and when you look at it, you actually are required to create a function in it, a method called actionPerformed. And that's the main purpose of ActionListener, is that it's going to require a function called actionPerformed. ActionPerformed takes an action event called E as its single parameter. And what that does essentially is this. It says, when I got clicked, then I'm going to say something. I'm going to say, I got clicked. So far, you okay? It's going to get weird. All right, so I've got this special class, event handler, which is designed to help me handle this event. Okay, now let's take a look at how we've changed our main program. Not much, but a couple of really key things we have to do here. So all this is the same. All of this is the same, except now take a look at this line right here. I have a new variable that is of type event handler. That's the class I just made. So event handler, maybe it's Canadian, So my event handler is a new event handler. All right, that's fine. Why do I need that? Well, because if I want a button to do anything in Java, I need to tell it what object is going to handle its events. And in this case, okay, I'll use the event handler object because I have one. That's right there. So I'll say, hey, your action listener, when you get clicked, I want you to go to this class and do what it says. So that's how an action listener works. If you forget this line, then your button will do nothing. You know, you can click it all day and nothing will happen. So you want to make sure that for any of your buttons, you have an action listener. All right, now the rest of this is working. So let's go ahead and run this and see what it does. So here it is. I've got my input, SDF. I click it. Now, nothing happens here, but if you look down at the bottom, look at the console, woo-wee, it can tell it got clicked. Well, that's a good sign, isn't it? So we can tell that the event handler is doing what it's supposed to do. When this gets clicked, it says, oh, my event handler is that's one of these things, and it knows to print out I got clicked. Well, that's a really good start, except that wasn't what we wanted to do here, is it? No, what do we want to do? We want to be able to grab the text. Sorry, let me pull it back up. We want to be able to pull the text from the text box, create a new greeting, and put that in the label. All right, fine, let's do that. So here we go. Let's see, what is that thing called? Let's see, input and output. So I'm going to do this. After I got clicked, I'm going to say string username gets input dot get text. Now you can look that up. Text elements have a get text method, which is obvious. It gets the text. Okay, I like it. Do you like it? We'll see if it works. In fact, I'm just going to stop right here because it won't. Okay, everything is looking just great. I'm going to type in my name, Andy. Oops, being weird there. That's weird. That's very weird. Why is it doing that? Okay. And then I'm going to hit the button. Ready? I got clicked. And then it stops. I'm not sure we recompiled. Let's check and see. Oh, okay. We tried to recompile, and it crashes. What? Why did it crash? It says it can't find input. It's complaining about this line right here, and it says it can't find input. Well, why can't it find input? Well, There's a good reason it can't find input. Does input belong to event handler? No. Input belongs to HighUser. They're totally different classes. They don't know anything about each other. Ugh. And so that's a bit of a problem. You would be tempted to make the event handler a totally separate class like this, because it kind of is. The problem is, if it's a separate class, it doesn't have access to anything that belongs in the main class. And I've seen a couple of different solutions that programmers have done over the years. And they're kind of awkward, so I'm going to show you what I think is the best solution. So, so here we are. The thing is, I would like this whole thing. I'll go ahead and take that out. It turns out we'll have the same problem if we try to apply it to the label. It doesn't know what the output label is. It doesn't know what the input object is. Now, one thing is we could pass those as parameters, I suppose, but that seems complicated and really unnecessary. Let's compile this again and make sure that when I've taken that out, it still runs okay. All right, now this is running all right. Now the thing is, wouldn't it be cool if this class itself could also be its own event handler? That would be pretty awesome, wouldn't it? I mean, because then we wouldn't need a separate class and we could access all of our own components and everything. So it seems like that would be the ideal solution, is that the class could be its own event handler. But here's the problem with that. How do I get this thing to act like a J-frame? Well, I inherit J-frame. How would I get it to act like an event handler? Well, I would inherit event handler. Now, if you're in C++, you can have more than one parent class. That's no problem. But in Java, that's not allowed. Let me see if I've got my tablet here. I'm going to show you why that's a problem. Okay, and the reason that could be problematic is that you could have what's called a inheritance. So I'm going to take that out. Okay, let's see. I want to draw. All right, so let's say I have a class here. Where's my pen? I'm going to have a class. There's my class. Can you see my class? All right. Now, it has two children. So class A has a subclass B and a subclass C. So that kind of looks like yo. Pretty good so far? Now, I have a new class called D, which inherits from both B and C. You see that? Now, here's why this is problematic. What if A has a foo method, a method just called foo? So A has a method called foo. Now, will B and C also have a method called foo? Yes, they will. And it's possible that they'll do something different because they can be overwritten. Here's the really crazy thing. What about D? Will D have a method called foo? You guys have no idea what I'm talking about. That's all right. It's worth it. D will also have a method called foo. And this is the really confusing thing, is that foo might do anything that any of the others above do. So it's nearly impossible to figure out what's going on. I know if you can't hear me, you're just going to have to wait for the video. But this is the problem with what's called multiple inheritance. So, so what happens in C++ is sometimes you run into these diamond-shaped inheritance trees, which cause some huge problems. So Java just says you can't do that. You cannot do multiple inheritance. So even though we would like this class to be inherited from both the J-frame and the event, the action listener, that's the kind of object that can listen to button clicks, we can't do that. Let me show you what we do instead. It's actually really very clever. If you look here at ActionListener, I've got to back up another level. Java.auth.events. There's the action listener. The action listener isn't actually a class. What it is instead, it's called an interface. And what that means is quite simple. It is defined like a class, but it only has empty methods. So the methods are defined, but there's nothing in them. And so when you implement an action listener, then you are just promising that you're going to have an action performed. That's all. So you're saying, hey, if I implement action listener, then I promise, I pinky promise that I am going to have an action performed method. Okay, so now let's take look at the last version of this and see how that works out. So here I have HighUserListener. It extends JFrame. That's its parent class. But it implements ActionListener. I thought you said we couldn't do multiple inheritance. Well, we can't. But see, interfaces don't count. In an interface, there's no actual body to the methods, so it's fine to implement as many as you want because you can't run into that diagonal inheritance problem. And so what happens is I can only extend one class, but I can implement as many interfaces as I want. And now that I have implemented this action listener interface, now I have promised that somewhere in this code I will have an action performed method. And there it is. So now what I'm really saying is this class is not only a JFrame, but it also will act as its own event handler. And so let's take a look at how things change. This part hasn't changed at all. This hasn't changed at all. Most of this hasn't changed, but take a look at line 36. That has changed. I no longer have a separate event handler class because this HighUserListener is its own event handler. So my add action listener is myself. It's like on the movies, you know, those guys in the movies who do all their own stunts. It's like I'm doing my own stunts. I don't have another event handler. I am my own event handler. So what this is really saying is if you're looking for an action perform method, I have it right here. I've got my own action performed method. Then, of course, you have to write it or it will not compile. Public void action performed, action event E. So this is saying, all right, something interesting has happened. So what do we do here? So the E just tells us about the event. And we don't care about it right now, but we'll utilize it in a little bit when things get more complicated. So system.out.println, I got clicked. That works. But now take a look at this line. Line 43 broke before. It wouldn't work. But this time it will. And the reason is txt input exists. There it is, txt input. And it's in the same class, so it'll know where it is. LBL output is a label for output. You notice how I named them this time, make them easier to understand what sort of thing it is? That's kind of nice. It's set text method. I can pass it some text, and that should make it say something interesting. Well, let's try it. Let's compile this. Let's run it. Let's see if it works. HighUserListener. Okay, here we go. It's a little more elaborate. Please type your name, Andy and friends. Click me. Let's make it wider so we can see what's going to happen. Hi there, Andy and friends. Woo-hoo, woo-hoo. It worked. This is pretty exciting because we can now get our program to respond to text input from the user and to manipulate it. So that's pretty awesome. Yes, it is. Okay, we have a few more minutes, so I'm going to do some other things that weren't actually. I'll move along a little bit just so we can move forward. Here. All right. Let's do a little more. I'm not going to do these applet things. Applets are a cool idea, but they're done now. They just don't happen. Let's take a look at this program. Basic layout. And I'm going to show you some of the layout handlers so you can see what's going on with layouts. Okay. All right, compile and run. All right, now here is, now we're going to talk about these various layout managers. And there's a number of layouts available to you. Here's one of the most common ones called Flow layout. And inside this thing, you'll see that I have buttons that are of different length. The labels have different length words on them: short, medium, long, empty, really long. And as you look, what's interesting is when I change the size of this, it changes behavior. And so, you know, today in web layout, we're all excited about responsive design, this idea that we can design a web page that looks pretty decent on a phone or on a desktop machine. But we've been doing this in Java for 20 years, really. So it's really not that shocking of a thing. And what happens is all of the layout managers do their best to figure out how to lay things out, even if you don't know exactly what size things are. And so it tries hard to make a guess on the size and position of elements. If you look at this thing, I haven't put any code in here that says how big things should be or where they should go, except for this part right here. I've just said, hey, manage the layout with the flow layout, and that will determine the rules for the size and position. Given that, let's try and figure out what the rules are for a flow layout. And it turns out they're pretty straightforward. In the flow layout, you make each element only as big as it has to be, kind of like the pack. And then, if possible, you place the next element to the right of the previous one. If you can't, you put it down on the next line. And it looks like there's a little bit of a gap between them, so they're nicely spaced. So the nice thing about the flow layout is it's very, very easy to use. That is nice. And it works, but it can be ugly and kind of unpredictable. So let's take a look. Here we have our object. So container P gets this.content pane. This seems a little off here. Okay, that's fine. Okay, so panel set its layout to new flow layout. That says when I add things, use the flow layout rules. Now in this case, I haven't done the event handling because I don't really care right now. I just want to look at layout. Now I'm going to say, I'm going to run the add controls function, which my indentation got really weird here. There we go. So now I'm going to say, and that's off too. Wow, the whole thing is messed up. I don't know what happened. I switch around between editors, and sometimes the different editors have different thoughts about what's appropriate. Okay. So now we'll say add controls. And the add controls function, well, we'll add these buttons. Nothing shocking there. That all makes plenty of sense. Okay, and just to make sure I haven't broken anything, we'll save it, recompile, and run. Okay, super. All right, so now, yeah, that's working, and it changes as we expect. So let's take a look at another example. Let's do the grid. Now, we started to do the grid, but let's learn a little bit more about how the grid works. All right. New. Save it as grid demo. Compile. Please compile. There we go, and run. There it is. Okay, so Same exact elements. So I used the same add controls method. I didn't change anything. The only thing different is that I have changed to a grid layout. And in the grid layout, as you recall, I can specify the number of rows and columns. But the interesting thing is what happens when the thing changes size. Okay, it always tries to make it 2 rows and 3 columns. Well, that's useful. Now, sometimes that's really ugly. But that's really what we're aiming for, is 2 rows and 3 columns at any time. And it changes not only the position, but the size. In the grid, every button is the same size, or every element is the same size, and it expands to fit the size of the available space. And so a grid with 2 rows and 3 columns is going to do its best to make 2 rows and 3 columns in any case. Sometimes that looks good, sometimes it doesn't. Well, this is okay. Can we change it? Well, yes. Let's go 3, 2. So I'm going to say this time 3 rows, 2 columns. Now it's interesting, there's 6 cells and there's only 5 elements, but the truth is it doesn't matter. It does what it can. So it'll be pretty close. Let's run this. Oh, compile and run. And looks like, okay, there we go. 3 rows, 2 columns. Oh. So that's different. Okay, you're right. Yeah, that's different, but it works out just as well. Now here's the question. Sometimes, you may not know exactly, and so a lot of times you might do this. How about this? I'm going to do 2, 0. Well, that would mean 2 rows and 0 columns. That seems to make no sense. Well, we don't really mean 0 columns. Let me show you. 2, 0 means make it 2 rows and as many columns as you need. Oh, so when I put a 0 in one of these things, I really don't mean 0. I mean, I don't care. I want it 2 rows, and I don't care how many columns. Likewise, we could do it this way, 0, 2. That would mean 0 rows, which really means I don't care how many rows, and 2 columns. Let's run that and see if it works. So 0 rows, 2 columns. That's frequently how you'll see a grid layout done, is that we'll specify either the rows or the columns. This is one of my favorites. Actually, I use this a lot, a grid layout of 0, 2. It's really handy for like forms and stuff. So I'll often use this as one of my favorite layouts. For very, very simple things, I might do what you saw in the Hello World example, a 0, 1 layout, which means I want to have 1 column, don't care how many rows. Stack everything up. It's taking a second to pop up. There it is. So that's another really handy one. Generally, you don't do 1, 0 because that puts everything in a line down the bottom. Sometimes you do. But for labels, they tend to look better, labels and buttons, and most of the GUI elements tend to look better stacked on top of each other. Okay, that's pretty great. All right, let's take a look at another layout manager. All right, and that would be 1 column, 1 row. We've already done that. Let's do the border layout. Now, this one is interesting because it does seem really weird. Yeah, it is the most commonly used. Okay, let me show you. All right, so there's the border layout. We'll save it. Compile it. And we'll run it. And this thing looks absolutely awful. Okay, how does the border layout work? Well, as it resizes, it appears to have only 5 places you can put things. And that's true. There are only 5 places you can put things. You can put things in the center, and you can put things in a north, south, east, and west panel. Okay, That seems crazy, but okay, I get it. And you have to specify where you put it. If you don't specify, it puts it in the center place. Now look at what happens with the size. The top and the bottom ones, so north and south, are only as tall as they have to be, but as long as they possibly can be. The east and the west, so west, east, are as tall as they can be after accounting for the top and bottom, and only as wide as they have to be. Center takes up all the rest of the space. Okay, so let's take a look at how this is used. Everything's almost the same, but now we have a new border layout. Okay, great. And I do everything the same way, p.add. But now, because this is the border layout, we have to tell it where we want to place every element. And so that's a constant built into the border layout package. So we're going to say, hey, I want you to put short in the east spot, medium in the north spot, long in the south spot, empty in the west spot, really long in the center spot. So if you don't remember this, the default is center, and it will put all of them in the center, which will make no sense at all because they'll all step on top of each other. You'll only see the last one that you placed. So the add controls is the same exact thing. The only thing that's different is that I have specified where to put these. Now, okay, you probably understand how this works, and you would agree, all right, it works, but man, that's stupid. I mean, when will you ever need this? And why in the world would this be the most commonly used layout? It seems so limiting. All the others, at least you could choose to put more than 5 elements in. Well, here's how it's really used. Is we'll normally do things in a panel. What? Okay, let me show you this. So new panel demo. All right, that looks pretty great. Compile that. Run it. Come on. Now this one is interesting because if you look at this layout and you see how it's behaving, it really doesn't seem to be following the rules really well. If you look at it, I have a grid of 1 column here, and I have what is that? That's a flow layout on the bottom. But then if you kind of look out a little bit, you can realize the whole thing is using a border layout because this grid is in the center and this thing is in the south. Oh, so what am I doing? I'm nesting layouts inside of each other. That's really the key to a powerful layout design, is that you nest these various components inside each other to get clever combinations. And that's how most of your apps are going to be written, actually. So let's take a look at how this is done. And the secret is a new object called the panel. So a panel is both a component and a container. And so we can add a panel just like any other component, like a button or whatever you want. We can add a new panel, but the panel can also get its own layout, and we can add things to the panel. Oh, okay. So the top part of the program hasn't changed at all. The main panel's layout is now border layout, but now take a look at what we do. Inside here, we build the center panel. So I have this center panel, which is a new panel. Now the center panel will set its layout to a grid of 1 column and add stuff not to the main panel P, but to the center panel, P center. Oh, sneaky. Now, at this point, none of these buttons are visible yet because I've added them to panel center, but I haven't placed panel center. Okay, now I'm going to build the south panel. So that's a new panel, set its layout to flow layout, and then add these buttons to that guy. So now these are not added to the main panel either, but to the south panel. So now I'm going to build my main object, which remember was set to border layout. But here's the cool thing. As far as the main panel is concerned, I just have two components, pCenter and pSouth. Of course, those have other components embedded on them. So pCenter is this guy that contains these two buttons. pSouth is this guy that contains these three buttons. And so when we look at it running, did I kill it? Okay, I'll rerun it. When you look at it running, you can see how flexible this is. Basically, what you're going to do is you're going to use the border layout to get the big, broad picture of how things go. And you hardly ever put anything on more than two components. So if you want buttons on the side, you may do a panel here and a main panel. If you want buttons on the bottom, you may do it this way. You may want things on the top as well, and that's perfectly fine. Or things on the right. And typically, your simpler programs, that's all they're going to need, is to have some components, your main activity in the center, and then some various things on the sides. Could I go another layer deep? Oh, absolutely. Absolutely. So I could have this broken into a grid that has grids inside that. There are some other layout mechanisms, and we'll talk about them next week. But for now, I think this is enough that you can start building some really intriguing programs. And that's what we're going to do after we get this card game done, is we're going to build another program that will actually allow us to interact and solve an interesting problem. All right, well, I think this is enough today. We've had some connection problems, so watch this video. I guess you already have been, I hope. And I'm looking forward to hearing from you. Hey, next week, no, I think next week is normal, but we're going to have Thanksgiving coming up here. I don't know how that works with you guys, so I'll try and hook up and make sure we know what's going on. And it is just about time for us to start thinking about our final project, so we will be communicating about that soon. All right, thank you so much for your time. You are amazing. Have a great week. I'll talk to you later.